So good afternoon, everybody, and thank you for coming along. And you've obviously heard a lot of presentations this morning so far, and those have been great. But I'm going to do something slightly different. I'm going to tell you a story today. Now, I've got two young kids, and because of that, I love telling stories. So we're not going to dive deep into a lot of services. What we're going to talk about today is a mystery that we came across when one of our clients was trying to implement a new system. So rather than a deep technical dive, it's a bit of a mystery story. It's a who, or rather a what, done it. So if you like stories, they'll start in a couple of different ways. You've got your traditional approaches, once upon a time, which is probably one of my favorites. But for the audience today, maybe prefer this one. But actually, many of you, I guess, work in IT. And so our stories tend to start like this. Something goes wrong. Why is he doing that? You end up looking through logs, through code, trying to work out what's happening. And that's the kind of talk I'm going to go through today. But before I get into the details, I'll give you a bit of an introduction. So, yep, that's me. My name is Simon Hanmer. I'm an AWS community builder. Community Builders is a program that Amazon run to encourage people who are interested in the technology to share their knowledge, learn about things, do blogs, videos, or like today, presentations. I know there's at least one of the community builder here today, but there's probably a few. So anybody might see the badges or the backpacks. Any questions about the program, feel free to reach out to us. On the professional side, I work for a company called Global Logic. And Global Logic are one of those firms that you probably have used our products hundreds of times, but you never know about it. We don't tend to be branded. So if you bought a burger in McDonald's, use those big touch screens. We help develop those with McDonald's. If you've used an electric vehicle, or in fact most modern vehicles, we've helped write the embedded software in those, things like the virtual cockpits. If you've got navigation devices on your phone, we're involved in those. One of the products that we did develop that I'm particularly proud of is we do a lot of work with med tech companies, and one of them came to us because there's a real need about people who've had cardiac issues. If you have a heart attack, there's a good chance it's going to happen again in the near future. So we developed a vest with it's got sensors in there, there's some AI, and it will monitor the heartbeat. And if anything goes wrong, it's actually got a defibrillator built in. So it's actually really nice to have products that save lives. Unfortunately, I'm not in that team. We have a more traditional consultancy team. Many of you, I'm sure, have worked with very similar teams. We do things like digital transformation, migration projects, helping run efficiently in the cloud. Back to your optimization talk there. And one of the nice things about this is that we get to work with a variety of clients, and sometimes they come to us and we'll get some things not quite right. And that's one of the things I love about the job. So in this particular case, we had a client, and they were trying to implement a monitoring and observability system. And they were gathering lots of data from lots of different applications and trying to build, if you like, a big dashboard so we could see what was going on. And in this particular part of it, we were using good old S3. It tends to come up a lot of the time, and obviously with a talk about S3 keys, that's what we're going to look at. The system was trying to do something very simple. So our logs would get uploaded into a standard place, and these are things like S3 access logs, website logs. But our application that was going to monitor them needed these to be in a particular place. So all we were doing was moving from A to B. Seems like a very simple problem. So what we built, we started with S3. So S3 is just an object store. We can put data in there. S3 looks after it for us, makes sure it's highly available. But there's some other nice functionality in there. We can do things like replication to keep our data stored across other buckets. In this particular case, the thing we were using was S3 events. So when something happens in an S3 bucket, that will generate an event, and that will get sent out to various places. And you probably heard people talking about EventBridge this morning. EventBridge does a very simple job. It listens for things happening, and if those things happen, you can write rules to trigger something else. Now, we could have just triggered a Lambda. That would have been the easiest approach. But there's a problem. We were generating a lot of data, millions of events every day. And we talked about service limits there. There are limits on how many Lambdas you can have running at the same time in a single account. And we would have hit that very quickly. So we made an architectural choice to use SQS, simple queue system. And what we would do is we'd take that the object is there. But we come to look at it, and it's not there. So we had this strange situation where the system's telling us that files are there, but when we come to look at it, they've disappeared. So this obviously caused us some problems. And what was even stranger is if we went and looked in the console, we could see those objects were there. If we took the details and put them into the queues ourselves, it would work 100% of the time. So it wasn't an issue, say, encryption or permissions, anything like that. It was something a little bit strange, and we had to do some digging to work out what was going on. So, what was happening? And I'm going to give you a little bit of a history lesson here. So S3 was announced a long time ago, 2006. And as it says there in the original blog post, we've rolled out, and it's highly scalable, low latency, and it's also a very resilient service. Now, S3 was actually the second service announced. Does anybody know what the first one was? SQS, yeah. Which is a bit strange, because SQS is for talking to other things, but there's nothing there for it to sort yet, but that will come along. I'll tell you what, I'm just going to grab a water very quick. So, S3 is a great service, and it makes our lives easier. Many of you will have used it. And back to this original announcement, it also told us it's going to provide very high data availability. And it does that by transparently storing our data in multiple locations. So behind the scenes, what it's actually doing is you upload your object to the bucket, that data gets replicated out to multiple availability zones. Availability zones are just the data centers in the back. They provide us that resilience. Now, that takes a finite amount of time. And depending on things like underlying network latency, one region might take a little bit longer than another. And generally, you can't control which availability zone you're going to talk to when you make these CLI calls. So if you're really quick, you can make a query before your data's there, and it will come back, and we'll get our no such key. And this isn't a problem that's unique to S3. This is a problem that's been around really since the start of distributed systems. Lots of examples out there. I'm going to quickly skip through those. If you've used DNS, who has used DNS here, making changes to IP addresses and names? It takes a while to get out there. It is a couple of hours, something like that, sometimes even days. And that's because there are thousands of servers that provide that DNS data back to us. It takes time for it to get there. In the AWS world, we've got DynamoDB. It works on the same kind of model. Data is replicated everywhere. With DynamoDB, you can actually pay extra and make sure that it won't return the data until it's written to all regions. So we were starting to get a feel. We thought we knew what the problem was. It's an issue around consistency. But as we started to dig into it, we came across this blog post from Jeff Barr again, I think it was. Yeah. So a couple of years before our problem, this was announced. S3 update now has strong read after write consistency. You write your data, when you come to read it, it's going to be there. It's got strong consistency. So this obviously was a bit of a confusing point at this point. And I'll tell you, we lost a couple of days because you go, well, that's not the problem, it must be something else. Until we came back and revisited this blog post. So I'm not going to expect everybody to read it at the back. But what it says is effective immediately, all get, put, lists, operations that involve tags, metadata, things like that. Those are all strongly consistent. Now that is a very specific list. That tends to imply there are probably services in the background that aren't strongly consistent. And guess what? The service we were using isn't on that list. Copy. Copy is an atomic operation with S3. It's not a read and a write. It's an operation you say, do this thing. And it's not strongly consistent. So we had a good feeling now. We knew what the problem was. So the next question is, well, given I'm standing here today, the answer is not surprisingly yes. And the reason we could do this is because of that architectural decision we'd taken at the beginning. Because we'd used SQS, SQS has a facility where you take those batches, it will process them. Originally, if it failed, all of the messages in the batch would go back into the queue and you would have to reprocess them. Now that introduced its own set of problems. You had to be aware of, have I processed this message before? In our case, that was easy to tell. Is the file there? But that meant it was quite inefficient. If you're doing a batch of 100 objects that are coming into the queue, you've got to go over them all again. So, as I quickly gave you a preview of, Amazon did what Amazon loves to do. You've probably heard this term before, undifferentiated heavy lifting. They will look at a problem that their customers are having. If lots of people are seeing the same problem, they will find a solution. And in this case, they introduced a fix, or a feature if you prefer, called partial batch responses. And what it lets you do is you can tell SQS which messages have failed, and only those go back in the queue. So it will give us much more efficient processing. And that's what we did. And it's really simple. You just keep track of which messages have failed, which ones give you the no such error. You build a little data structure and you pass it back at the end of the Lambda. So that's kind of our story. But if you're going to have a story, you should really have some morals to take away. That's the best stories. You learn something from them. So I'm going to share 3 points with you, just to think about. First of all, when we started in IT, we were working with real servers, and you tended to concentrate on your code problems. When you work with serverless, you have to think about other things that are inherent in the system. You have to think about your network latency, have to worry about consistency. All these pieces have to talk to each other. So don't just think about the code, think about the environment you're going to be working in. It makes an impact on how you write stuff. Secondly, this is the one that got us, don't skim read the documents. Don't just look at the headlines and assume you know what's happening. Go into the details, it's important. And finally, the one that Amazon loved to roll out at every reInvent, everything will fail eventually. It's true. That sounds like a really easy system to implement. But yet again, we saw this failure. Make sure you design your code, taking those things into account. Think about your failure modes, how you're going to handle them. Make sure you do testing. Don't just test your code, test the environment. Look at things like fault injection service, Amazon's chaos engineering service, where you can turn off a VPC or a subnet or introduce latency. Test those things as well. that's it for myself. So a very brief story. I'm aware I'm getting in the way of you and lunch. So I will be around the rest of the day. If there are any questions, feel free to grab me. LinkedIn profile there. But thank you very much for your time and enjoy the rest of the day.